today's segment, and here we are going to look into polynomials with the assumption that you are a beginner. So if you are, even though you are in primary school or you are in secondary school or outside secondary school, this is for you. So what are polynomials? From the word poly means many. So what are monomials? Let's take it from what a monomial is. What is a monomial? From the word mono means single. So let's talk about monomials first. If you have this 2 as a number, we all agree that this is a single entity, so it's a monomial. So if I have 3x, this actually means thrice of a certain number that is unknown. Suppose x is 2, so 3x actually means x multiplied by 2, so which is 6. So in this case, this x is 2. So x is the unknown. So anywhere you see x in mathematics, it represents a number whose value is not defined. So 3x is also a monomial. If I have, let's say, 5x squared, this is also another monomial. So 5x squared actually means 5 multiplies by the number raised to the power of 2. X squared actually means we are multiplying x by itself twice. So this actually means 5 times x. So if x is 2, same way here, it means 5x squared becomes 5 times 2, and that is 20. So in this case, 5x squared means what? 5 multiplied by the square of the number. So it's also a monomial. Let's even go as far as if we have 2x cubed. This actually means 2 multiplied by cube of a number. Cube of a number actually means you multiply the number by itself 3 times. For example, 2 raised to the power 3 means 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So all these are all monomials. Now the question is, what are now polynomials? When you combine at least 2 monomials, we get what we call polynomials. When 2 monomials are combined, they are called polynomials. The first part is binomials. So when you say bind, from the word bind means 2. If you combine 2 of any monomial, we get binomial. For example, if we add 2 and 3x together, so we start with 3x plus 2. This is a binomial. We can add this and this together. 2x cubed plus 5x squared is a binomial. We can add this and this together. 5x squared plus 3x. All these are binomials. Then we have trinomials also. A trinomial is gotten when 3 monomials are joined together. For example, let's join these 3. So we have 5x squared plus 3x plus 2. This is a trinomial. We can combine with this one, 2x cubed plus 5x squared plus 3x. Is a trinomial. We can combine 2x cubed plus 3x plus 2 is also a trinomial. So all these are trinomials. What if we are combining 4? We can call it quadnomial. So for quadnomials, we have 4 monomials. Let's start from this one. We have 2x cubed plus 5x squared plus 3x plus 2. We can have x cubed plus 4x squared plus 3x minus 5. We can have x to the power 5 plus x to the power 4 plus x to the power 3 plus x to the power 2. We are just counting the numbers of monomials. 2 monomials, binomials. 3 monomials, trinomials. 4 monomials, quadnomials. So, and they are all polynomials because we have more than one monomial. Now, this particular binomial is a linear expression. It's a linear expression. I will explain the meaning of linear. This particular one is called a quadratic expression. And this particular, this is for this. And this particular example, this third one here, is actually a cubic expression. So linear expressions, quadratic expressions, cubic expressions, they are all polynomials. Now, this particular monomial is called a monomial of degree 3. What's degree 3? We are talking about the power of the unknown. This is a monomial of degree 2. Degree 2 because the highest power of the unknown is 2. This is a monomial of degree 1. Degree 1. While this one is a monomial of degree 0. Why is it degree 0? Because here I can still write x raised to power 0 here. Why? Because x raised to power 0 is 1, 1 times 2 still means 2. So this particular expression, the calculated expression, is a constant. Why? Because we have no unknown. Because this x power 0, we can also remove it completely. It still remains 2. So when x is not there at all, it is constant. So for this particular one, this expression is called linear. This particular one is called quadratic. This is called cubic. So for a cubic expression, the highest power is 3. So all this one we have here, this is a cubic expression, this is also a cubic expression. This is not a cubic expression, although it is a polynomial. Now, this is a quadratic expression, yes. These other two are not quadratic, although they are trinomials. So for this one we have, they are all binomials, but only this one is linear. Why? Because the highest power is 1. This is a constant. Linear, if the highest power is 1. So for linear expression, the highest power is 1, degree 1. For quadratic, the highest power is 2, degree 2. For cubic, the highest power is degree 3. And so on. Now, let's write more examples. Here I'll write some examples of linear expressions. We have quadratic expressions and cubic expressions. Now, considering these following examples, all these are linear expressions, all these are quadratic expressions, and all these are cubic expressions. Although for all this linear, this is a binomial, this is just a monomial, but they are all linear. They are all quadratic. This is what? Trinomial, binomial, just a monomial. And for this four, this quadnomial, trinomial, binomial, monomial, well, they are all cubic. For every linear expression, we can express them in general as writing what? As plus b. Meaning, we have a constant added to unknown multiplied by a coefficient. And the highest power here is 1. For this one, it is as squared plus bx plus c. Meaning we always have something squared. The unknown will square it, we have x and the constant. For this one, we have as cubed plus bx squared plus cx plus d. So for degree 3, the highest number of monomials is 4. For degree 2, the highest monomial is 3. For degree 1, the highest monomial is what? Is 2. But it's possible they are less. But the thing is, one thing must always be there. For example, here, x must always be there. X should always be there. This a can never be 0. So a can, because once a becomes 0, the answer just means this b becomes a constant. Similarly, if a here becomes 0, this s squared disappears, then this becomes linear. So for all this condition, the value of a can never be 0. So as soon as a is not 0, this is the general expression for every linear expression. This for every quadratic expression. This for every cubic expression. So in primary school, you'll be limited to linear expressions. In secondary school, in junior secondary school, you'll be limited to quadratic. You'll be introduced to a bit quadratic. Then in senior secondary school, you do this quadratic in depth. But you hardly touch degree 3, even in senior secondary school, except for subject like further mathematics, or if you're writing mathematics in JAM. So this is like primary school, junior secondary school, senior secondary school. We have higher degrees also, degree 4, degree 5, even degree 10, and some other complex expressions. So for example, for people that are going for competitions like Olympiad and the likes. So, but in short, this is everything on the board are polynomials. So we are starting from the simplest, which are linear expressions. We are done linear, move to quadratic. We are done quadratic, move to cubic. So if I call linear expression n, Let me call quadratic Q. Let me call cubic C. Quadratic actually when you multiply two linear expressions together. When you multiply two linear, you get quadratic. You understand it as move on. When you multiply three linears, you get cubic. Or we can say linear times linear is quadratic. So I can replace one with quadratic. So for a cubic, is gotten when you multiply one linear, one quadratic. Quadratic is gotten when you multiply two linear. So linear is the foundation of every other expressions. So by the time we are done with linear expressions, they will now go to what we call linear equation. Now let's move to linear expressions. But before that, let's talk about constants first. Constant. What are constants? Just numbers. They are numbers. They do not change with any other unknown. They have no connection. Example: 2 is a constant. 5 is a constant. 7 is a constant. Constants are not always whole number. 7 over 2 is a constant. Minus 5 is a constant. 10 raised to power 10 is also a constant. They are all constant. So, one thing you have to know is that as a beginner in mathematics, which I will assume, you must know the basic operations that we have. Basic operations in mathematics, and they are basically 4, or let me say 5. So we have addition, we have subtraction, we have multiplication, we have division, and lastly we have index. Let me use n to represent that. Let me start with this. For example, if I have 2 raised to power 0, if I have 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, until we get 2 raised to power 10, what does it mean? 2 raised to power 0, it is 1. You understand this when you get to indices. Indices is the plural of index. We have a power. So what is on top of the number is all called the index. So 2 raised to power 1 is 2, meaning the number standing alone. For this one, this actually means we multiply the number by itself twice. This means we multiply the number by itself 3 times. And this is we multiply the number by itself 10 times. Times 2, 10 times. So 2 times 2 is 4. Next is 8, like that. So we have 1, 2, 4, 8, 16, 32, 64 until we get to, I think, 2 raised to power 10 should be 1, 0, 2, 4. So these are powers of number, which you should know normally. So, but what I want us to do now is basically we should know how to add, multiply, divide numbers. So in primary school we should have done this. You should know how to add numbers. Addition is very easy. Multiplication also is easy. But you see the subtraction and division might be a bit complicated, especially subtraction. So first let's start with addition. Let me use these two numbers, 7 and 5. If I ask you what is 7 plus 5, you will have it out. Here we are adding numbers of a single digit. So you can count your fingers. Count 7 fingers and 5 and count all together. You get 13. And the previous you count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, you see, I haven't made a mistake. The answer is actually 12. So you know how to add. Very simple. What if they are numbers of 2 digits? I have 17 plus 15. All you do, you use what we call place value. Place them above this shoulder this way. 7 plus 5 is from here 12. But we cannot write 12 here because this is actually 12. This 12 means 10 plus 2. So we carry the 10. But write 1 here. Actually, it is 10 we are carrying. But write 1 here. So that we can come here and do 1 plus 1, 2, plus this 1, 3. But actually, this one actually means 10. This is 10 means 10 plus that 10, that's 30. 10 plus the 2 here, we have 32. So I think addition using place values. But in secondary school, even if you don't know how to add using this method, just use calculator straight. But I believe this is a normal thing you should know how to do. How to add. Addition shouldn't be the problem at all. Now, still on constant, my focus is here. Addition and subtraction. Now, let's start the following. What is 7 plus 5? What is 7 minus 5? What is minus 7 plus 5? What is minus 7 minus 5? What is 5 plus 7? What is 5 minus 7? What is minus 5 plus 7? What is minus 5 minus 7? So, this is the beginning of confusion for some people. They get confused when they get to some places. 7 plus 5, everyone knows the answer is 12. 7 minus 5 is 2. Why? You can just count 1, 2, 3, 4, 5, 6, 7. Remove 5. 1, 2, 3, 4, 5. What is left? 2. Even a primary student can do that. But you see this? These two confuses students. 5 plus 7 is also 12. Very easy to add. But this 5 minus 7, what if 5 minus 7 in primary school is impossible? Why? We cannot remove 5 from minus 7. So, like I said, I want to assume you're a beginner, so let's take it from here. Now, this minus 7 actually means we have what? Negative of what? 7. So, I can write this minus 7 as minus 2 plus minus 5. Why? If we can add 1 plus 1 plus 1, 2 plus 3. We can also add minus 1 plus minus 1 plus minus 1, which is also minus 3. So minus 7 actually means what? We can add minus 1 minus 5 to give us minus 7. Why am I doing that? Because here I have 5. So if I have minus 5 plus 5, it actually means we are adding two opposite things and you cancel out to give us 0. This minus 5 plus 5 actually means 5 minus 5, which is 0. So we are left with only minus 2. So minus 7 plus 5 is minus 2 straight. My method might seem to be much more complex, but you understand why I'm doing that later. So now, let's use another way to explain this. So, minus 5 plus 7, we can rearrange. We can write minus 5 plus 7 as plus 5 minus 7. So, which becomes what we have here. Note, all this number, when no sign is written, it means we actually have plus. We have plus here. So, when no sign is there, what is there is plus. Just know that. Put that at the back of your mind. So, I can turn this. So, what is 5 minus 7? It's not possible to remove 7 from 5. So, what can you do? You can flip it and write what? 7 minus 5 instead. 7 minus 5 is what? Is 2. But because we flip, when you flip positive, it becomes negative. So, the answer is minus 2. Same on this. Or, another method. Minus 7 means you are owing something. I can say plus 5 means I have 5 oranges. But I'm owing someone 7 oranges. Since I have 5 at present, but I want to give you 7. So I'll give you all the 5 I have. So I'll still be left with 2 to give you later. Minus 2. So any of the 3 approaches. Then lastly, whenever we are combining two numbers, the sign of the final answer is the sign of the bigger number. For example, the bigger number here is 7 and the 7 is plus. So that's why the answer here is plus. The bigger number here is 7, the answer is plus, this one is also plus. But here the bigger number is what? Minus. So the answer was a minus. If they have different signs, just subtract the small number from the big number. Now in this case, they have same sign. Whenever they have same sign, you add the number straight. 7 plus 5 is 12. The bigger number is 7, just minus here. Or in another way, you owe someone 7 oranges, you owe another person 5 oranges. Up together, you are owing 12 oranges together. So from here, 5 minus 7, you say impossible. 7 minus 5 is 2. Bigger number is 7, put minus here as a sign of this. Why for this one, minus 5 plus 7, we can rearrange. As minus 5 plus 7, same thing as what? Plus 7 minus 5. 7 minus 5 is what? 2. Or you can think this way. I'm owing 5 oranges, but I have 7. So I'll give you all the 5 I'm owing, no problem, and I still have what? 2. Why for this one, I told you if they have same sign, just add straight. So 5 plus 7, 12. Then the answer still means minus. What I just explained here is the first point of mistake or the first problem some students face when it comes to algebra. So to see if you've gotten this, let's do a quick test. Now for this first question, 8 plus 3, very quick, you will tell me 11. 8 minus 3, you will tell me 5. Now minus 8 plus 3 is what? 5 seconds. You are correct, but you are wrong. The answer is actually minus 5. Why? Bigger number is 8, the answer has to be minus. The other different sign, just subtract 3 from 8. 5. What about this one? Yes, you are correct. No, you are wrong. You are correct. Why? Because they have same sign. You are going to add 8 plus 3 is 11. Bigger number is 8 and it has minus as sign. Or you are owing 8, you are owing 3. You add 3 plus 8. Yes, you are correct. You are also correct. 11. 3 minus 8. Since they have different sign, there's invisible clause here. Whenever the signs are different, you have to subtract. 8 minus 3 gives 5. The bigger number is 8 minus. So the answer is minus 5. How about this one? You can rearrange minus 3 plus 8 as 8 minus 3. So what's the answer? Correct. 5. For this one, same sign you have to add. 3 plus 8, 11 minus. So, I believe by now, you shouldn't have any issue with addition and subtraction. These are for constant. Now let's now go back to linear expressions. Same here, we are going to start with addition and subtraction. Now look at this. What is this? 2x. What is this? 7x. These are two different linear expressions. Is there more? There is a constant there. So let's start with the one without constant. So what are you going to do here? So like we did it the other time, let's add. If you have 2x plus 7, what's the answer? 2x minus 7x, what's the answer? Minus 2x plus 7x, what's the answer? Minus 2x minus 7x, what's the answer? Let's start with 7x. 7x plus 2x. Note this. What we did for the constant is the same thing we are doing here. Just note that in general, for linear expressions, we focus on, we add. You cannot not add 3 at the same time, you can only add 2 at the same time. So let's suppose we have a linear expression, we have ax, and we have another number bx. So when we are adding, we only add the coefficient. So this becomes what? A plus b all into x. So for this first question, the answer is actually 2 plus 7 all in x. But you don't need to write this, you can write the answer straight, which is what? 9x. For this one, it's we are adding 2 and minus 7 into x. For here, we are adding minus 2 and 7 into x. For this one, we are adding minus 2 and minus 7 into x. Here, 7 plus 2 into x. 7 plus minus 2 into x. Here we have minus 7 plus 2 x. Here we have minus 7 plus minus 2 into x. So what will be the final answer here? Remember we've done this before. What is 2 minus 7? Minus 5x. So what is minus 2 plus 7? 5x. Minus 2 minus 7? Minus 9x. 7 plus 2? 9x. 7 plus minus 2. Note 7 plus minus 2 is same as 7 minus 2. Why? Note this quickly. So whenever here it actually means we are multiplying this positive sign and negative sign together. Whenever positive comes with negative or negative comes with positive, the answer is always negative. We only get positive if the two numbers are positive or when two numbers are negative. So it means same sign, when you multiply same sign, you get positive. When you multiply different sign, you get negative. Please note this. So yes, plus times minus is minus. 7 minus 2 is 5. So the answer here is 5x. Here, minus 7 plus 2, that is minus 5x. Please note that, minus 5x. Minus 7 plus minus 2, we have minus 7, we have minus 2, and we are adding. That's equal as minus 7. Plus minus is minus. I told you, if you have same sign, what happens? You just add 7 plus 2, 9. You have negative x. So these are all the final answer. So in next exercise, we are not going to write what we have at the middle here. Just do that with our mind. Note this before we move on. 9x plus 3x. 9 plus 3, 11. 11x. Okay. 9x plus 2x minus 5x. What's the answer? Don't panic. 9x plus 2x is 11x. Pair them up first. We are doing this first. Then now minus 5x. Then from here, 11x minus 5x, that is just 11 minus 5, and that is 6x. Done. Okay, another example. For this, minus 2x minus 3x plus 4x minus 5x. Don't panic. We can pair them up. We can take this one first, and this one. So we now ask, minus 2x minus 3x, minus 2 minus 3 is minus 5. So the answer is minus 5x. Here we have 4x minus 5x. 4 minus 5 is actually minus 1. So the answer is minus 1x. Although most times in maths, we don't like writing what? 1. But as a beginner, I can just leave it like that. So then, minus 5 minus 1, I told you, same sign you have to add. 5 plus 1, 6. That is minus 6x. Oops. Seeing this ordinary, you are already scared, don't be scared. Deal with what you have in the bracket first. So this remains minus. So let's do this one first. 5 minus 2 is 3, is 3x. Leave this minus here, come back here. Don't rush here. For this one, pair them up first. Let's do this first too. These two first. Minus 2 plus 7 is actually what? 5x. So here I'll write 5x plus 3x. The one that answer there, minus 3x. So here we still have this bracket here. So here I have minus 3x minus 5x plus 3x is 8x. Then minus 3x. So this time around, what we have beside 3 here is positive. So the here just becomes minus 3x minus 8x minus 3x. So what are you to the next? Do not panic. Pair up first. Note this is 3. So you can take this first to first. So here, minus 3 minus 8, same sign you add. 3 plus 8, 11. So that becomes minus 11x. What do you have here? Minus 3x. Again, minus 11 minus 3, same sign you add. 11 plus 3 is 14. That's minus 14x. So the final answer here is what? Minus 14x. The first rule in mathematics, do not be scared. No matter how the question looks, just start from what you know. You get to where you want to get. All the examples we look into in so far, they are the one involving the linear expression without the constant part. Let's now take the one with the constant part. Now, suppose we have a linear expression of ax plus b. Another one of, let's say, cx plus d. What happens if you want to add both? So if you have something like this, you have to rearrange. So the linear, or this degree 1, degree 1, those one that have same degree will come together. They are called like expressions or like terms. So you have to rearrange so that like terms will be beside each other. So if you want to add this together, what we'll do is this ax and cx will be beside each other. So I'll write ax plus cx. So this b and this d, the constant will come together, plus b plus d. As for this, we can now add their coefficient. That becomes a plus c into x. B plus d. Forget about this. Let's take examples. So let's suppose we have 2x plus 3 plus 5x minus 2. What are you going to do here? So rearrange first. So 2x plus 5x plus 3 minus 2. 2x plus 5 is 7x. 3 minus 2 is 1. So that's the final answer. As simple as that. So instead of adding together, what we will have is minus. Suppose we have 2x plus 3 minus 5x minus 2. Please, I put this bracket because of this minus. Whenever you are subtracting, the minus is affecting everything here. So first, let's remove the brackets. So this minus affects this. What we have here is plus. Minus plus is minus 5x. But this minus is affecting this minus. Minus with minus gives plus. Then we have 2. Next is to rearrange. These 2x go with this minus 5x. So 2x minus 5x, 3 plus 2. 2x minus 5x becomes minus 3x. 3 plus 2 becomes 5. So that's the answer here. Let's give a more complex example. Rule number 1, do not panic. If P is 3x plus 1, Q is 4x minus 3, R is 1 minus 5x. express 2p plus 3q minus r in terms of x. Don't be scared. What is this telling us is that this p, instead of writing this p here, I'll write 3x plus 1. So here, this 2 remains outside. What's that p? 3x plus 1. Here. What is this telling us is that this p, instead of writing this p here, I'll write 3x plus 1. So here, this 2 remains outside. What's that p? 3x plus 1. Finish. This is equals 2p. Plus, what do you have here? We have 3. So what is q? Q is 4x minus 3. So replace this q here with what we have here. 4x minus 3. There we have what here? Minus. What is r? 1 minus 5x. Then here, there's a little problem here because I assume you are not a beginner. So since it's time of beginning this lecture, you may not understand what to do next here. Note, if you have a number outside this bracket, this number is for those two entities inside. So this is what we call expansion with a single what? Bracket. So let me just explain that one here and I'll come back here. Expansion with a single bracket. Now suppose I have this. The number is outside, let's call it A. Inside here we have bx plus c. So this A is for both B and both C. So this A will multiply this B. This A will multiply this C. So at the end we are having A multiplying B plus this A multiplying C. And that is the answer. E.g., suppose I have 2 into 4x plus 3. So I'll do 2 times 4, that is 8. Then write that as 2 times 4x. Then the sum we have here is plus 2 times 3. 2 times 4 is 8x plus 6. That's the answer. Coming straight or directly. 2 times 4, 8x. 2 times 3, 6. Let's solve this question and let's take more example under this expansion with a single bracket because some are more confusing than others. Now let's continue. Based on what we did here, 2 times 3, 6. So I'll write 6s here. 2 times 1, 2. I'll push 2 here. 3 times 4, I'll write 12 here. Then 3, here I have plus 3 minus 3. Plus times minus is minus. 3 times 3 is 9. Now this minus is affecting both 1 and this minus here. Minus affecting this one becomes minus 1. Minus multiplies minus give plus 5x. What is next is to collect like terms, meaning writing the terms that are like the same. So this is 6x, I'll write the 6x here. This is 12x, I'll write it here. Then this 5x, I'll write it here. Then for the ordinary numbers, here I have 2 plus 2. I have minus 9 and I have minus 1. So you can do that separately. 6x plus 12x will give us 18x. 18 plus 5 will give us 23x. So this is 23x. 2 minus 9 is what? Again, 2 minus 9 is what? Minus 7. It is minus 7. Then minus 1 again. This alone is minus 7. Then you have another minus 1 here. Minus 7 minus 1 is what? No, we are adding 7 plus 1 is 8. Then you put minus there. Minus 1, 7 minus 1 is minus 8. So the final answer is what? 23x minus 8. Back here. Why removing a single bracket, expansion with a single bracket? These are the possible combinations we have for the sign. So for the first one, it's very straightforward. 2 times 4, 8. So I write 8 with x. 2 times 3, 6. Simple. That's the example we have here. Now I have a minus. Minus 2 times 4, that is minus 8x. Minus 2 times 3 is minus 6. Because minus times 3 is minus 2 times plus 3. And I said earlier, minus plus gives minus. 2 times 3 is 6. If you multiply numbers of different sign, the answer is negative. Number of same sign, the answer is positive. Here, 2 times 4 is 8x. 2 times minus 3 is minus 6. Here, minus 2 times 4 is minus 8. Why is it minus? Because this is positive number, negative number. Negative positive number give us what? Negative. Now, what about negative number? The answer is positive. Why? Minus is positive. 2 times 3 is 6. 2 times minus 4, that is positive, negative. That's how we negative. 2 times minus 4 is minus 8x. 2 times minus 3 is also minus 6. Why? Positive, negative. For last one, minus 2 times minus 4 is plus 8. But we don't write the positive if it's starting, if the number is starting. Minus 2 times minus 3 is plus 6. Why? Because we are multiplying same sign. Minus minus plus, minus minus plus, plus minus minus, plus minus minus, minus plus minus, minus minus plus, plus plus plus, plus minus minus, minus plus minus, minus plus minus, plus plus plus, plus plus plus. Things as simple as this. You can solve a long question, and because you refuse to put the correct sign there, you get the final answer wrongly. That is why mathematics is very, very sensitive. A single error, then everything becomes wrong. Note all this while what we're doing is addition and subtraction. Although we've done a bit of multiplication, what is what I believe you should know. For example, here we multiply 2 and 4 to get 8. But what we are doing mainly here is addition and subtraction. And here we are dealing with only odd numbers. Sorry, I mean whole numbers. Ordinarily, I have to move to expansion with 2 brackets. But if I expand 2 linear expressions, I'll get quadratic. But I don't want to go to quadratic yet. So let's go and take an example whereby we have fraction. Examples involving fractions. Now look at this. 2x plus 3 is the linear expression. X plus 5, another linear expression. So let's also have something like this. Divided by 2, divided by 3. So here we are adding 2 linear expressions. What will be the answer? This is very difficult for a beginner. Yes, I want to assume so. So what I'll do is, let me go back to primary school. Let's suppose x is 1. Suppose x is 1. 2 times 1, 2. 2 plus 3, that's 5. Over 2. Here, 1 plus 5, that's 6. Let me put, instead of 3, let me put 5 here. So that is 6 over 5. At a point in time when I was growing, if I have this kind of question, I would say the answer is 11 over 7. Why? 5 plus 6, 11. 2 plus 7, 2 plus 5 is 7. This is wrong. We can't add fraction this way. So if you are thinking that we should add this with this, this with this, that will be wrong. So what are we going to do? We have to take what we call the LCM. We can only add 2 fractions if they have the same denominator. For example, if I say 1 over 3 plus 2 over 3, the answer is 1. Why? 1 over 3 means out of 3 we have 1, out of 3 we have 2. Definitely if you add this 1 plus this, you get the whole, which is 1. That's 3 over 3. That's the rule. We can only add if they have the same denominator, and we can only add the numerator. Then choose one of the denominators. So what I'm going to do is, what can we do to ensure that these 2 and 5 are the same? Now we are going to change 2 fractions. So this is what I'll do. I know if I multiply 2 by 5, I'll get 10. 5 by 2, I'll also get 10. But to be sure that we are not changing the question, so we multiply the numerator here by 5, the numerator also by 5. We have 2 here. I'll multiply this one by 2, this one also by 2. Why? 2 divided by 2 is 1, so I'm still multiplying 6 by 5 by 1. 5 by 5 is still 1, I'm not changing anything. So here we just 2. 5 times 5 it is 25. 5 times 2 is 10. Plus 6 times 2 is 12. 5 times 2 is also 10. Now they have the same denominator, we cannot add. Since there is a denominator, we put 10 here, they will do what? 25 plus 12, that is 37. So that's the answer. Bam. But to save space or to save time, we notice that this 10 is the LCM of 2 and 5. If you know how to do LCM, it's the LCM of 2 and 5, the lowest common multiple of 2 and 5. Now these 2 numbers, they are prime, not just relatively prime, they are prime numbers. So if those numbers are prime, just multiply them, that will be LCM. So another method is, I'll come and write here 5 over 2 plus 6 over 5. Using your primary school method, look for the LCM of 2 and 5, you get 10. Put a longer line here. Then you come here, 2 divides 10 is 5. Then multiply the 5 by this 5. 2 here is 5, then 5 multiply the 5 up here. Then whatever is plus. 5 in 10, 2, 2 multiply 6 here. So at the end we have 25, 2 times 6, 12, over 10, that is 7 over 10. Still works. So this method works always, but this one is faster using the LCM method. Or another method, but sometimes you can make your work longer, or you can get bigger values of answer, or an answer with bigger value that I need to be cutting. So all I do, this 5 by this 5. 5 times 5, I'll write 25. 2 times 6, I'll write 12. 2 times 5, I'll write 10. So what's answer straight? 37 over 10. It always works. Yes, but I'm wondering, oh, this is the best approach. Yes, but what if you have big numbers? Suppose I have 1 over 10 plus 3 over, let's say, 30. So using this approach, you do 10 times 1, 30. 10 times 3, 30. 10 times 30, 300. Then we add, I have 60 over 300. So the problem with this method is, if you use this method, at the end you get a big number. They have to be cutting. From here, 0 cancels 0. So 2 in 6 is 3. Then 2 in 30 is 15. 3 can still go 3 here, 1, 3 here, 5. 1 over 5. Now, that is using this method. The method here for this. Let's now use the second method, this one. Let's use it again. So I have 1 over 10 plus 3 over 30. Using the LCM method, we know vividly that the LCM of 10 and 30 is 30. If you use the LCM approach. Or simply, if a number can divide the other, the bigger one is the LCM. So we come here, 10 in 33, 3 times 1, 3, plus 30 in 31, 1 times 3, 3. This is 6 over 30. Well, the only difference is that unlike this one, here, we are going to cut from here, not from the beginning. So if you do this, you can get 1 over 5. So this method here and this same. This with this. Can we use this butterfly method for this one also? Yes. So we have 1 over 10, 3 over 30. So you come here, you multiply this one by 30 over 30. This one by 10 over 10. Then we are having 30 over 300 plus 30 over 300. Am I right? Yes. So pick one of the denominator 30. 300. That is what? 60. Then at the end, same thing we got here, you get 1 over 5. So this method with this are the same. So here we have 3 methods in adding fraction. So but which approach is the best? The best approach is to find the LCM. The best approach is to find the LCM. So now let's go back to addition or reflection. Now for the solution, the LCM of 2 and 5 is 10. 2 in 10, 5. 5 applies everything here. 5, open the bracket and write 2x plus 3. Or they have here plus. If it's minus, write minus here 2. 5 in 10, 2. 2 into x plus 5. Then from here, if you expand, 5 times 2 is 10, you have the x. 5 times 3, 15. 2 times x, 2x, 2 times 5, 10 over 10. Then rearrange 10x plus 2x plus 15 plus 10, everything over 10. 10x plus 2x is 12x plus 25 over 10. And that is the final answer. Let us make this question a bit more difficult. Let's turn it upside down. 2 divided by 2x plus 3 plus 5 divided by x plus 5. What's the LCM? This time around you are shocked. Why? Because what you have here are not what? Numbers. You have letters there. Don't panic. This 10, same thing as 2 times 5. 2 times 5 gives us 10. So I'll assume this 2, this 5, multiply this and this together. So what's the LCM? The LCM is just 2x plus 3 multiplying x plus 5. After getting the LCM, what do? We divided this number with this. 10 divided by 2. Or 2 divides 10. 10 divided by 2 gives us this. So same thing. The whole of this divided by this. So what we have here is actually 2x plus 3, x plus 5. Want to divide it by what we have here? 2x plus 3. So what happened? This will cancel this, you let x plus 5. So if 2x plus 3 divides everything here, you will let to this. So 2x plus 5 multiplied 2, so we have 2 into x plus 5 plus x plus 5 divided x plus 5 will be left to this one, and this one will multiply x 5 into 2x plus 3. Now 2 times x 2x, 2 times 5 10, 5 times 2x 10x, 5 times 3 15. Everything over. Now we now have two brackets. I have not explained expansion of two brackets, and the good news is you are not even meant to expand the denominator. So you leave the answer as 2x plus 3, x plus 5. Next is to rearrange what we have here. But let me jump a step. Instead of rearranging and writing 2x plus 10x, 10 was 15, we can just do it directly. 2x plus 10x is 12x. 10 plus 15 is 25. Then over everything we have there, 2x plus 3, x plus 5. That is everything here. It is not difficult. It's just mindset. Like I said, number one, never be scared. Let us take much more complex examples. Now, for this question, same way, same approach. Although here we have three entities, we are still going to take the LCM. So, and what's the LCM of 4, 6, and 8? If you don't know that, go and look for your younger brother in primary 3 or 2, or let's say 5, to explain how the LCM can be gotten. But in short, since 4 can divide 8, the LCM of 4 and 8 is 8, so let's leave out 4. So the LCM of 6 and 8 represent the LCM of the 3, which is going to be, okay, let's do that quickly, in case you know before and you've forgotten. 2 here 3, 2 here 4, 2 here nothing can happen, 2, 2 here 3, 1, then 3 here 1, 1. Then the LCM is the product of everything here. 2 times 2, 4, 4 times 2, 8, 8 times 3, 24. So the LCM here is 24. Then 4 divides 24, give us 6. 6 multiply everything up here. What do you have here? 6. 6 in 24 is 8. Note, we have minus here, all here with minus. Then 6 in 24 is 8 into brackets 2x plus 5. Then what do you have here? Minus. So write minus here again. 8 in 24 is 3. Then 3 multiply 1. Then next is to expand. 6 times 1, 6. 6 times 3, 18. Now, this minus will affect these two. Minus 8 times 2. Minus plus, that will be minus 16x. Minus plus 3 minus 8 times 5, 40. Minus 3 times 1 is minus 3 over 24. So we can rearrange this with this. So we can write 18x minus 16x plus 6 minus 40 minus 3. This and this together, this and this together over 24. So 18x minus 16x, that is 2x. 6 minus 40, impossible. Then we write minus. 40 minus 6, 34. Then minus 3 over 24. So here I have 24, 2x rather. Minus 34 minus 3. We have same sign, the answer is minus. 34 plus 3, 37 over 24. That's the final answer. Let's take another example. 2 minus 3 into 4x minus 1 over 5 minus 3 over x. Don't panic. If you have a question like this, what's the first thing? Every number must have a denominator. If it has none, put over 1 there. The next, you check what is the LCM of 1, 5, and x. As soon as you have x here, just multiply. 1 times 5, 5. 5 times x, 5x. So the LCM is 5x. So 1 divided by 5x is 5x. So 5x multiplies 2. So we have 5x times 2. And you have minus here. Put the minus here. 5 divided by 5x is as though you are having 5x over 5. 5 cancels, that's x. So 5 divided by 5x is x. X times this 3 here, we have minus 3x into 4x minus 1. You already have here minus. X divided by 5x, meaning from 5x, remove x, that's 5. Then 5 multiplies 3. Then from here, 5 5x times 2, that's 2 times 5, 10. So this is 10x minus 3x into 4x minus 15 over 5x. We cannot add this with this because they are not like terms. And here, ordinarily, we are expanding one bracket, but there's something I want to avoid here, which I have not explained. How do you multiply this together? How can we multiply this together? Let's come back here. Although this shouldn't be a big deal. Now, this is what you do. Minus 3 times 4 is minus 12. Minus 12x. Sorry. Minus 3 times minus 4 is minus 12. Then x times x. When you multiply a number by itself twice, that's s squared. Then minus 3 times minus 1. Minus times minus is plus. 3 times 1 is 3. And this 3 has x with itself. So, if you now check, this 10 and this 3, they are like terms, but this is x, this is x. These two are not like terms, this is s for this is x, so you cannot add these two. You can only add this 3x with this 10x. So if you do 10x plus 3x, that will be 13x. So this is 13x. Then minus 12x squared minus 15 over 5x. You can stop it here. So that's the final answer. So I believe by now you already understand how to add linear fractions together. Ordinarily, the next thing we ought to move into is linear equation. But before we move to linear equation, we've done addition, subtraction. I think we cannot do multiplication and division, although you might need to understand some algebraic identities before we move on. Now, for this multiplication and division, let's start with constants first. Suppose I have 2 divided by 5 times, let's say, 15 divided by 8. So if you want to multiply here, this is what we do. Before you multiply, check. Do we have any of the denominator that will common factor with the numerator? In this case, which is yes. So this is 2 over 5 times. This 15 is actually 5 times 3. And this 8 is actually 2 times 4. I put this 5 times 3 here so that this can cancel this. 5 here 1, 5 here 1. 2 here 1, 2 here 1. So I have 1 times 3 times 3, which is 3. Here I have 1 times 4, which is 4. So the final answer is 3 over 4. It can be two fractions, it can be whole number with a fraction, and the likes. What if it is division? Suppose I have 5 over 18 divided by, let's say, 4, let's say 6 over 12. No, this is over 30. So this is for multiplication, this is for division. So when you have division, the rule is you have to change the sign to multiplication. It is easier to solve using multiplication and division. So anytime division is turned to multiplication, this fraction will turn upside down. You take reciprocal of the other side. It's actually one of the laws of indices, but for now, just take it this way. When division is turned to multiplication, the numerator becomes denominator, the denominator becomes numerator. Then from here, we can now start cutting. So, what is we can go here? Let's compare this with this. So here, 3 can go here. So 3 in 6 is 2. 3 in 15 is 5. Then 2 can still go in this 30. 2 in 30, 1. 2 in 30, 15. And I think from here, the standard is common again. So all we have here is 5 times 15. All we have is 8 times 1. And this becomes 75, 8. So this is the main idea when you have multiplication and division. So we can only divide the numerator and denominator. 5 can divide 15, 5 can divide 2 if they have common factor. 8 can divide 15 if they have common factor, 8 can divide 2 if they have common factor. If a division, we turn division to multiplication, and for this one we take the inverse, the reciprocal. of both sides. Let's now take an example involving polynomial. In this case, linear x. Now look at this question. 2x plus 4 over 3 divided by 4 over 9x. So what are you going to do? We can just write. Now first, let's observe. When we observe here, I have 2x. And this 4 is actually 2 times 2 over 3. I'll turn this into times. Then it's turn to 9x over 4. Now when we check the numerator here, 2 is common. So if we clean this 2 here, and we clean this 2 here, we can bring it outside. It's all called factorization. If you expand this, you get this back. And from here, let's see, what do you think can cancel? 2 here 1, 2 here 2, 3 here 1, 3 here 3. So at the numerator, we have x plus 2, we have 3, we have x. So I say 3 times x is 3x, times everything we have here. So that is what? This with this is 3x. Then with this bracket, x plus 2. Denominator, we have 2 times 1, 2. Final answer. The only thing I need here is to factorize 2 out here and turn the division to multiplication. So other examples we want to write might involve you to understand some identities, and I don't want to go there for now. But what you have to understand now is, whenever you turn division to multiplication, you take the reciprocal of the fraction. Now let me try to scatter heads more with this question. Like I said in mathematics, rule number 1, do not panic. So all I write here, I'll come and write 2 over x plus 1 times 4x plus 1 equal 9 times 9 into x plus 1 over 2. Division, I turn to times 3 over 4x plus 1. And recall I told you, numerator can always cancel denominator. As far as we have there is multiplication. Now if you observe, x plus 1 cancels x plus 1. So this is 1, 1. 9 here 1, 9 here 1. 2 here 1, 2 here 1. 4x plus here 1, 4x plus 1 here 1, 4x plus 1 here 1. So what I have upstairs, 1 times 1 times 1 times 1 times 3, that is 3. Over 1 times 1 times 1 times 1, that is 1. So what is the final answer? 3. So as complex as this is, the answer is just 3 straight. Do not panic. Now, before we end the lecture, let's take common mistakes. Oh, for this question, you say 2 here 1, 2 here 2. So the answer is what? 1 times 3, that's x plus 5 over 2. For this one, oh, 9. So I can say 9 here 1, 9 here 2. So that's 2x minus 1 over 2. Oh, for this one, 4 here 1, 4 here 1. That's 1x, which is x minus 1 over 1. Wrong. We can only cancel numerator and denominator if what is beside them, between them, is multiplication, not addition or subtraction. Suppose what we have is 2x into 5 over 4. That's what we can cancel. You can say 2 here 1, 2 here 2. So the answer is 5x over 2. Or this one we have 2x times 9 over 18. 9 here 1, 9 here 2. So the answer is 2 here 1, 2 here 1. That's x. So we have 4x times 1 over 4. 4 cancel 4. So the answer is just x. So we can only cancel or divide if what we have between the two monomials, it is multiplication, not addition, nor subtraction. Another common error. While we can express 2x plus 3 over 5 as 2x over 5 plus 3 over 5, yes, it's allowed. In mathematics, we can split the denominator. But if I have 5 over 2x plus 3, it is not equals to 5 over 2x plus 5 over 3. This doesn't work. This works. So meaning, if you have a monomial, at the denominator we can split. But if we have polynomial, at the denominator we can never split. We can only split if we have what? A monomial. Unless you don't take what is here as a single entity. Like example of what I'm saying. Let me explain. I said this one is not equals to 5 over x plus 5 over 1. But if we have x plus 1 over 5, it is equals to x over 5 plus 1 over 5. So we can split if we have a monomial. But if you have polynomial, we cannot split. Unless if you are taking everything as a single unit. For example, if I have 5x plus 2 over x plus 1. So if you are taking this as a single unit, they can write as what? 5x over x plus 1 plus 2 over x plus 1. Before we move to linear equation, let's take more examples under a case that involves addition, subtraction, multiplication, and division. For example, in this question, we are told that given that z is x minus 2 divided by 2x plus 1, express z plus 1 over z minus 1 in terms of x. In fact, what we actually want to get is z plus 1 over z minus 1. So what are we going to do? We are going to replace z with its value. And what is z from here? X minus 2, 2x plus 1. So instead of writing this z, I'll write x minus 2 over 2x plus 1. This is actually this z here. Then I have plus 1 beside it. Plus 1. Then here I have divided by. In this case, I'll write it as divided by. In order not to create confusion, I can put this inside brackets. This represents the numerator. This is z plus 1. This is actually z plus 1. So instead of writing z plus 1, we'll place z with x minus 2 over 2x plus 1. So for the denominator, we have z minus 1. So instead of writing z minus 1, we'll place z with its value. And what's all of z? We place z with what we have here, x minus 2 over 2x plus 1. Then from here, I don't need to put this bracket here. Doesn't matter because we're not expanding anything here. So what can we do here? Now we want to add a fraction and whole number. Then give a shortcut. Whenever you want to add a fraction with whole number, suppose you have a plus b plus c. So the shortcut is to multiply this b with c and write a plus this. Write this a, then what we have is plus b times c is bc, then everything over b. So for example, if I have 2 over 3 plus 4, I'll write 2 plus 3 times 4, 12. Everything over 3, and that is 12 over 3. So using this shortcut, we can easily simplify this. So if we apply that here, this equals to, then 2x plus 1 multiply 1. So first I'll write x minus 2, but we have the x minus 2, and this sign here plus this time this. 1 multiplies everything, remains that thing. So what we have here? 2x plus 1. Ordinarily I meant to put brackets here, but because we have plus here, it doesn't matter. So over everything here, 2x plus 1. Then we'll do the same thing here, divided by. Now this time around, what I have here, I have x minus 2. What's the sign here? Minus. Then this multiply 1. 2x plus 1 times 1 is still what? 2x plus 1. But if you leave it this way, you get it wrong. Why? Because this minus is for both 2x and 1. So we can just open the bracket to avoid confusion over 2x plus 1. Then here, we can continue by saying, we can rearrange. Here we have x plus 2x minus 2 plus 1 over 2x plus 1. Then divided by, for this case, I have x minus 2. So this minus affects both, so that will be minus 2x. Minus and plus is minus 1 over 2x plus 1. This becomes x plus 2x, 3x. Minus 2 plus 1, minus 1. Divided by 2x plus 1. Divided by, so from here, x minus 2x. X minus 2x is minus x. Minus 2 minus 1 is minus 3 over 2x plus 1. From here, we can now turn this this division to multiplication. So I have 3x minus 1 over 2x plus 1 times, when we change this division to multiplication, this denominator becomes the numerator, that's 2x plus 1. over this numerator becomes numerator minus x minus 3. And if you look very well, you see that here I have 2x plus 1, 2x plus 1, so they can cancel each other. So when we check up, what we have is 3x minus 1. When we check the denominator, what we have is minus x minus 3. And this is our final answer. Or if you notice, minus is common here. So you can still say this is what? 3x minus 1 over, if I factorize minus out, this becomes x plus 3. Because the minus is for both x and 3 now is out. And this minus, we can still bring it up here. So this is same thing as, so you can see our final answer is minus 3x minus 1 over x plus 3. The minus here, we can also bring it here. You can also bring it to the, you can also write it this way. The same thing. You can put it here, it's the same. So this is our final answer. So it means z plus 1 over z minus 1 in terms of x is what? Minus 3x minus 1 over x plus 3. In fact, we can still write this further. Like I said, we can bring this minus up here. If you bring minus up here, it becomes minus 3x minus 1 over x plus 3. So this minus can affect everything. So this becomes minus 3x minus minus, that's plus 1 over x plus 3. Final answer. If no minus to come first, you can write the answer as 1 minus 3x over 3 plus x. I swap it. I wrote 1 first before 3x. I wrote 3 before x. So this expression, this expression, this expression, this expression, they are all the same. In fact, this expression. So ordinarily we could have stopped here, but if it's objective question, you might not see this, you might see this, or this, or this, or that. So from here, this is, I think, one of the toughest questions that can be given under addition, subtraction, division of or multiplication involving linear expression. In case you don't really understand, slow down, rewatch the video, practice the questions again by yourself. All the questions, all the previous questions. Okay, the next thing as promised is to first look into linear equation. What is the difference between linear expression and linear equation? For example, if you have something like 2x minus 1, this is an expression. It's a linear expression because the highest power of x here is 1. So let's suppose I have a monomial, let's say 5. This is another expression, but this is a constant, or just call it a constant monomial. If we equate both, this becomes an equation. Ordinarily, this expression here and this, they are not the same. But for a particular value of x, they become the same. Let's see. So if you are told to solve this, we are told to solve. We are meant to solve. When you are told to solve, it means you are looking for the value of the unknown. So this is it. So this 2x is what we want to get. So we can write it as 2x. This minus 1 we can cross over this equality sign and becomes plus 1. Any value here, when it moves here, is going to swap. The sign will change. If it's minus, it turns to plus. If it's plus, it turns to minus. So from here we have 2x equals 2. 5 plus 1, 6. To be able to get the value of x, we have to get rid of this 2. What link 2 and x together is times. To remove x, we have to remove 2, we have to divide. So next is to divide both sides by 2. So I'll do the other by 2, the other by 2. 2 cancels 2. So x becomes 6 over 2, x becomes 3. So it means if x is 3, this and this will be equal. So let's try to put 3 here. 2 times 3 is 6. 6 minus 1, 5. Every other value of x will never give us 5. Only when x is 3. We've not gone to graph, but if you are to sketch this as a function, you get this straight line graph. You get this kind of graph. For this 5, you have a graph this way. Where they cross is our x-axis. The value here is 3. So this is a graph of 2x minus 1. The grade is 2, and it will cross y-axis as y is minus 1, the intercept. So, but for now, we don't understand what I'm saying here to get it. So, in short, equation involving when two expressions are equated. In fact, 0 itself is an expression involving a constant monomial. For example, let's suppose we are told that 3x minus 2 equals 0. This is an equation because we equated this with this, meaning for all value of x, will this whole expression be 0? So same thing we did there. So this minus 2 crosses, so solution. So you have 3x equals 2. When minus 2 crosses, it becomes plus 2. To get x, divide by 3. Divide by 3 over 3. So when it is x equals 2 over 3. So it means if x equals to 2 over 3, this whole expression becomes 0. Let's test. We have 3x minus 2, right? So replace x with what? 2 over 3. 2 over 3 minus 2. Here 3 cancels 3. That's 2 minus 2, which is 0. So meaning if x is 2 over 3, this equation stands. Another example. Suppose we have 4x minus 1 equals to 7 minus 2 into x plus 3. Remember the rule, do not panic. I have a bracket, then we have to remove it. So here we have 4x minus 1 equals to, notes. I believe you should understand board mass. If not, maybe we'll check the previous lesson, you see our explanation about mass. We cannot do 7 minus 2. We have to first prioritize opening this bracket because this bracket means we are multiplying. So you have to multiply first before you can add or subtract. So this 7 remains. Please don't make mistake. Most students will write 7 minus 5, then expand with 5. That is wrong. So leave this 7 alone. Then this minus 2 multiplies x. Minus 2 times x is minus 2x. Minus 2 times plus 3. Minus plus is minus 2 times 3 is 6. Then for this side, we can rearrange. Here I have 7 minus 6. So this remains 4x minus 1 equals to 7 minus 6 minus 2x. I only rearrange here. So this becomes 4x minus 1 equals to 7 minus 6 is definitely 1 minus 2x. So we cannot collect like terms. So we can make this minus here. So remember, when minus crosses, it becomes plus 2x. This is 1. When this minus crosses, it becomes what? Plus 1. 4x plus 2x is 6x. 1 plus 1 is 2. To be able to get the value of x, we have to divide both sides by 6. So I will do divided by 6, divided by 6. So therefore it means x equals to 2 over 6. 2 is common, 2 into 1, 2 into 6, 3. So the value of x for this particular equation is 1 over 3. Let us take more examples. Don't forget the rule. Don't panic. We have this question. Just go to the bracket straight. Solution. Here are 5. So minus 2 times 1 minus 2. Minus times minus plus. 2 times 3x, 6x equals to. Note, we are not doing 5 minus 2, 3. I've explained that previously here. Open brackets first before you proceed. 2 minus. Then here we have another inner bracket. So write this 3 here first. Now this minus is going to affect both x and 3. So it becomes minus x. Minus and plus is always minus 3. Then let's move on. Now here we cannot do 5 minus 2. There is no bracket here. 5 minus 2 is 3. Then I have plus 6x. We still write 2. This minus is for everything here. Or I can still write minus. Now if you notice, here I have 3 minus 3. 3 minus 3 is 0. So definitely the only thing that will be left here is what? Is going to be minus x. Because 3 minus 3 is 0. So this is 3 plus 6x equals to 2. Minus with minus this plus x. So from here we can collect like terms. Meaning, let's bring all the x together, the odd numbers together. So this 6x remains here, not moving. Note, the sign before a number is owned by that number. So this x owns this plus. So when this x crosses, it becomes minus x. This 2 remains here. This 3 has a plus here, although not written. So when this plus 3 crosses, it becomes minus 3. So 6x minus x, if you are confused, just know that if I have x, it means the coefficient is 1. So it means 6x minus x means 6x minus 1x. Meaning 6 minus 1, 5. So that is 5x equals to 2 minus 3 is minus 1. To be able to get the value of x now, we have to divide by this 5. So I have 5x over 5 equals to minus 1 over 5. We divide this side by 5 over 5. This cancels, so it means x equals to minus 1 over 5. All the examples we've done so far involve no fractions. So let's take an example with fraction. Example with fraction. Simplest one. Let's suppose I have x over 2 equals to 1 over 3. So what are we going to do here? If we have only two fractions, and what we have here is equality, we can do what we call cross multiplication. So what happens is this x can multiply this 3, this 2 can multiply this 1. So this x multiplied with 3, I have 3 into x, 2 into 1. So 3x equals to 2. To be able to get value of x, I'll divide by what? Exactly, by 3. So 3x over 3 equals to 2 over 3. Cancel, cancel. So therefore it means x equals to 2 over 3. Note, we can only cross multiply if you have only two fractions, so one on this side, one on this side. So let's take more examples on only two fractions, then we'll go to three fractions. Now suppose you have something like x plus 2 divided by 3 equals to 2x minus 5 divided by 2. No, let's say divided by 3 for easy. If it's a 2, we won't get the complete answer. We have 3 yes. So let's use another number, let's say 4, yes. So since we have two fractions, one here, one here, solution, we can just cross multiply. So this 4 multiplies this. So solution, we have what? 4 multiplying x plus 2, then equals to 3 multiplying 2x minus 5. So let's expand. 4 times x, 4x. 4 times 2, 8. 3 times 2, 6, which is x. 3 times minus 1, minus 3. Then we can collect like terms. But it's not a must you always bring x here and number here. Sometimes you can decide to bring the x here and number here. This time around, I would like to bring the x here. Why? Because this 6x is greater than 4x. If I bring it here, I'll be getting my x to be positive. So that I will avoid net minus. So this 8 remains with this plus. This minus 3 comes and becomes plus 3. This 6x remains. This 4 has originally plus behind it. I told you, whenever the sign is not written, it is plus. So when I bring it here, it becomes minus 4x. So from here, we have 11 equals to 6x minus 4x is definitely 2x. To get x, we divide both sides by the coefficient of x, which is 2. So we have x equals to 2x originally over 2 over 2. Cancel. So our x becomes what? 11 over 2. If you want to answer to be a mixed fraction, x equals to 5 number 1 over 2. Another example involving two fractions. Let's suppose we have 2 into 3x minus 1 over 5 equals to 3 into 2x plus 3 over 7. Don't panic, the first rule, do not panic. So same thing here, we are going to cross multiply. So this 7 multiplies everything here. So 7 times 2 is definitely 14. So we have 14 into 3x minus 1. 5 times 3 is 15 into 2x plus 3. Then let's expand. 3 times 14 is definitely 42. So we have 42x. 40 times minus 1 minus 14 equals to 50 times 2, that's 30x. 50 times 3, 45. So correct like terms, I'll bring this 38. So 42x remains here ordinarily. So when this 30x crosses, it becomes minus 30x. Why? Because it's having a middle plus here equals to this 45 remains with this plus at the back, but I'm not writing it because we are writing it first. So this minus 14 crosses and becomes plus 14. From here, 42x minus 30x is 12x equals to 45 plus 14 is 59. So here to get value of x, we divide both sides by 12. So here we have 12x equals 59 originally, divided by 12 over 12. So definitely our x becomes 59 over 12. Alright. Now look at this question. The pattern is a bit different. Unlike this one that we have ordinary number and the denominators, here we are having a typical expression. It's a linear expression here. So don't panic. Same thing, just bring this one to this side. So solution, we have 4 over 2x minus 5. When this minus crosses here, it becomes plus. That's plus, well, let me try the plus 2x minus 3. The plus is not necessary to be written. So here we can cross multiply. So this 4 multiplies everything here. So I'll open bracket and write 4 into 2x minus 3 equals to this 5 multiplies everything here. 5 into 2x minus 5. Then we can now expand. 4 times 2, 8. We have 8x here. 4 times minus 3, I have minus 12 here. 5 times 2, we have 10x. We have minus here. 5 times 5, 25. So we can collect like terms. Same way, this 10 is 1 and 8, so I'll bring this 8 here. So this 10x remains. This 8 has a visible plus here. When it crosses, it becomes minus 8x. This minus 12 remains. This 25, it is minus. When it comes here, it becomes plus 25. But its own plus is not necessary because it's 13. So from here, 25 minus 12 is 13. 10x minus 8x is 2x. We can now divide both sides by 2. So I have 13 because of 2x originally over 2 over 2. Cancel, cancel. So s equals to 13 over 2. So s equals to 16 over 1 over 2. Now let's now take cases involving more than 2 fractions. For this particular question, we have 4 fractions, but do not panic. In just a single step, we get rid of all the fractions straight. Now, when you have a question like this, the first thing is focus on the denominators 3, 2, 6, 12. If you look for the LCM of 3, 2, 6, 12, you are going to get 12. 3 can divide 12, 2 can divide 12, 6 can divide 12, so the LCM is 12. Then you multiply every fraction by 12. So originally here we have 4x minus 1 over 3. I'll multiply it by 12. Then here we have plus 1 over 2. We also multiply this by 12. Now equals to 3x plus 2. Also multiply by 12. Then we have minus x over 12. Multiply by 12. So since we apply both sides by 12, all the 12 here will cancel all the 12 here, so we're not changing the question. So why are we doing this? Because we want to get rid of all the fraction in one single step. So from here, 3 in 12 is 4. If 3 divide 12, we get 4. So we have 4 here, multiplying what you have here. Same way, 2 in 12 is 6. Multiplying what we have here. What you have here is plus. The what you have here equals 2. 6 in 12 is 2. So that 2 will multiply what we have here. Then here we have minus. 12 in 12 is 1. So that one multiply what we have at the numerator. So in short, 3 in 12, 4. Then 4 multiply what you have here, 4x minus 1. So here, 2 in 12 is 6. Multiply what we have here. 6 in 12 is 2. This is 2. Multiply by what we have here. 3x plus 2. Then put the sign here first. 12 in 12 is 1. That one multiply x inside the bracket. So from here, in just a single step, all the fractions disappear. So this comes back to normal linear equation. So now 4 times 4 is 16. So I have cx. 4 times minus 1 is minus 4. 6 times 1 is 6. Equals to 2 times 3x is 6x. 2 times 2 is 4. Then I have minus 1 times x, x. So from here, I can write this as 16x. Minus 4 plus 6, that's 2, equals to 6x. Sorry, 6x minus x is 5x. 6x minus 1x, 5x, plus 4. Then here we can collect like terms. 5x is smaller, so I'll bring it here. 16x here remains minus 5x. 4 here remains minus 2. 16x minus 5x definitely gives 11x. 4 minus 2 is 2. To be able to get the value of x, we divide both sides by 11. Originally, we have 11x equals to 2. Over 11 over 11. From here, this cancels this, so therefore x becomes 2 over 11. So whenever you have more than 2 fractions, just multiply by the LCM. If it's 2, you cross multiply. Now look at this. Look at this. All we have here and this, they are the same. Just that this is written in terms of fraction times this linear expression. Do not panic. Focus on the numbers we have at the denominator. 3, 5, 15, 3. If you look for the LCM of 3, 5, 15, 3, the LCM is 15. So multiply everything in the bracket by what? By 15. So instead of wasting your space writing 12, 12, 12, 12, you can write outside there. It means you multiply both left hand side and right hand side by 15. So we take them one by one. So everything here multiplies 15. And doing so, 3 will cancel 15. 3 in 15, thank you, that is 5. 5 times this 2 here, that is 10. So here we have 10 into x plus 2. Chicken up. We have minus here, put the minus here. Minus 5 here. 5 divides 15, that is 3. 3 times 1 here is 3 into x plus 1 equals to, what do you have here? 15. 15 in 15, 1. 1 times 1, 1. Minus 3 in 15 is 5. 5 times this x, we have 5 into x. Single step. So next is we can now expand 10x plus 20 minus 3x minus 3, 1 minus 5x. 10x minus 3x, 7x. 20 minus 3 plus 17 equals to 1 minus 5x. We'll bring this minus 5x here. So here we have 7x plus 5x. Why is it plus? Because this minus crosses the equality sign. This one, when this 17 comes here, it becomes minus 17. So from here, 5x plus 7x gives 12x equals to minus 16. So from here to get x, we divide both sides by the coefficient of x, which is 12 over 12 over 12. Cancel. So therefore, x equals to minus. That's 4 can go here. 4 here is 4. Here is the mixed fraction. X equals to minus 1 number 1 over 3. That is the final value of x. Let's take an example where the denominators are algebraic expressions. Look at this particular question. So same thing. Look for the LCM of 2x plus 3, 3 and 9. First, focus on the number. So the LCM of 3 and 9 is 9. So just negate this 3. So the LCM here will be 9 times 2x plus 3. So multiply all the expression by 9 and 2x plus 3. So here we have 4 over 2x plus 3 minus 1 over 3 equals to 1 over 9. So what's the LCM in this case? 9 2x plus 3. Why is 3 not there? Because LCM of 3 and 9 is 9. So we take the 9, not the 3, not the product. So what next? We can now multiply. Everything here multiplies this. So definitely just come here. Anything we have here, cancel what is common. So this 2x plus 3, cancel 2x plus 3. We let only 9 here. So that 9 multiply this 4. So we have 9 into 4. What do you have here? Minus. 3 cancel 9, that is 3. Everything here is 1, so 3 in 9 is 3. With its 2x plus 3. Everything multiplying this 1, which is still the same thing. Then 9 cancel 9, I have only this, multiplying 1, 2x plus 3. Although you might decide to combine this first as a single fraction, then you cross multiply, is an alternate method, but I prefer this. 9 times 4, 36. Expand 3 times 2, x, 6x. Minus times minus, minus times plus minus. 3 times 3, 9, 2x plus 3. So here, 36 minus 9 is 27. Minus 6x equals to 2x plus 3. I'll bring this plus 3 here, it becomes minus 3. 2x equals to 2x plus 6x. Because this minus is smaller, this minus I'm bringing it so that I will not have negative. 27 minus 3 gives 24. 2x plus 6x is 8x. To be able to get value of x, I will divide both sides by 8 over 8 over 8. Cancel, cancel. So x equals to 24 over 8. So therefore x equals to 3. I think with this we've come to the end of linear equation. Any other question you have that is more complex than this, just look so. Like I said, do not panic. Rule number 1, do not panic. Start from what you know and do what you can do. You see that at the end of the day, that question that looks so, cumbersome becomes so simple, and you get the final answer correctly. So now, all this while we're talking about only one letter since the beginning of this class. X. Is x the only unknown? So x represents a single entity that is unknown. Sometimes you can have two entities that are unknown. So this x is called variable. It means it can take any value. X can be 1 minus 1, 2 minus 5, 1 over 2 minus 8 over 3. It can be anything. So, but in case when you have two entities that are unknown, which is when you have more than one variable, we are going to use another letter to represent the variable, and the next letter we use after x is y. For example, let's suppose you have this expression 2x plus 3y equals to 5. Find the value of x. You cannot know the value of x if you don't know the value of y. So for this particular one equation, two unknown, it is impossible to solve unless you are given another equation or a hint. Perhaps you are told that x and y are whole numbers, so you can get the possible values of x and y. Or you are given another expression that says x plus y equals to 7. In this case, this is one equation, this is another equation, and these two equations, they are true for a certain value of x and y. So in this case, we have two unknown. So if you have two unknown, we need two equations. Then here, the two unknown are called two variables. If you have two variables, you need two equations or two ints to get the value of those variables. Then to solve this, we are going to solve it simultaneously. So this becomes simultaneous equation. So simultaneous equation involving two unknown. We can also have simultaneous equation involving three unknowns. For example, we have 3x plus 2y plus z equals to 1. So in this case, we have three unknown, then you need three equations. Let's say x plus y minus z equals to 4, and x plus 2y minus 3z equals to 8. So if we have three unknown, we need what? Three equations. So these three variables. So how do we solve equations with two variables? How do we solve equation with three variables? We've mastered how to solve equation with one variable. The examples I gave here involving those without fractions. Sometimes you can have equations involving two or three variables that will have fraction, or in fact that will have decimals. So it's getting more complicated, but it is still simple. From what you know, we always move from unknown to known. So in our next class, we are still under linear equation, but not one variable now. Linear equation with two variables, then linear equation with three variables. Then we are not done with linear equation. We can take word problems. Then after that, we can move to quadratic. Remember, we are still under polynomial. One area of polynomial which is linear. Thank you very much. See you next class.